Hello and welcome to Crazy Danish Hacker. Today we're going to try and crack some SMSs sent to this iPhone. So the first thing that we will need is that we will need airprobe, which is compatible with new radio 3.7 or above. So we will just git clone. And then we will just compile it. Run bootstrap first. Then run configure. And then run make. Now we need to configure and compile GSM receiver. So now that airprobe has finished compiling, we can move on to the next step. We will need a tool called gsmframecoder. We can get it from this website. And we will just open a new console window. And then we will go down to this directory, and no, we can't use git. We need to use vgit. And then we'll just create it here then. And then extract the file. And before we run it, we need to recompile it. So we can't run it right now. We need to make clean and then make. And then test that it's working. Good. So I've already sent myself some SMSs. So I've captured on the iPhone 4, and I've captured for around 1 minute or maybe 2 minutes. And then I used field test mode to find out which channel it is, but I don't know the KC or the encryption key, and I don't know the TMSI. But I do know that I've sent myself 4 to 5 SMSs, so that way I can try and guess the TMSI based on that information. So if you haven't recorded yet, then now is a good time to start. Make sure that your phone is in 2G mode by disabling 3G and 4G on your phone. You will also need to find out the ARFCN, or the frequency where your phone is receiving data from. You can do this by entering field test mode on your iPhone, by entering the following code, and then dial. Then you will go into these menus, and then you will note the ARFCN, which is 98. If you're not sure how to capture traffic, then please see one of my previous videos to learn how it's done. So first we will just do the old school decode, as we've done in other videos. Channel 94, yep. Sample rate 1 million. And we need to supply the C file. C file, that's channel 94. And Timeslot. Make sure Wireshark is listening. And enter. And wait. So now that it has finished decoding, we can try and take a look at the immediate assignment packages. So we are looking for a package that says channel description, and then we want to look at the time slot. So it's time slot 1, time slot 1, time slot 1, and timeslot 1. So we'll just stop capturing, Control W, continue without saving, and listen again. And then we will change it to timeslot 1 and run it again. So now we are decoding timeslot 1 for SDCCH8. And if we take a look at the first cipher mode command, we can see that it's A51. So we will just open gedit and we'll just note that A51 is in use. And then we will just take a look at the next one. That's also A51. That's also A51. So that's promising because we can only crack A51 at the moment. And let's see. There may be a fourth. No? Yes. Ah, yes, there is. And A51. So we got 4 of them. Cipher mode commands or CMC packets. So the next thing that we want to look at is the paging response. And we want to look at the TMSI to see that it's identical for all of these 4 packages or 4 streams. So in this case, we'll just copy it. TMSI. And then we will just take a look at the next one. That's also the same. That's the same. And that's the same. So that's very promising because that means that since nobody else were transferring data or sending SMSs on 2G GSM at the same time, and there are no other packages with the TMSI repeated 4 times, then it's safe to say that it is our phone. So that's very good. So now we want to look at the system information 5 packages because we don't need to look at the actual contents. We want to look at the GSM frame number because we need that. So we will just click value. So there is a system information 5 package here, and you can also use system information 5 TER or 6 for this, and you can also use empty frames like this packet. Now the thing is, I've only tested it with system information 5, but it should work with 5 TR, 6 or empty frames. So in order to provide input for Kraken, we need to XOR unencrypted input or unencrypted system information 5 packets, or just one, with an encrypted version of this. But since we can't see encrypted data, then we can only guess where it is. But the thing is, system information 5 packets are repeated every 102 frames. So that means that we can add 102 to this number and get the next possible location where there may be a system information 5 frame. So we will just try and see if we can find them. But before we do that, we need to use airprobe. So we will just see, that's not it. Here it is. So we need to use, more specifically, we need to go into source Python, and then we need to use go.sh because that's the fastest option. And then we will use the file, specify 64. This is the decimation rate, and we will specify 1s because it's timeslot 1 for SDCCH8. And then we want to pipe the output, including errors, to a new file. And then we want to wait. Just make sure that we're not listening, because otherwise it may try to decrypt it again or show it in Wireshark. We don't need that. So we'll just wait until this is finished. And meanwhile, we will just add some numbers in our calculator. Now it's important to note that we can add numbers to this frame here, 102, and maybe guess where the next location of this may be after ciphering mode command. In some cases, there may be a ciphering mode or system information type 5 packet shown just after ciphering mode command. In that case, you will have to select the one after if the numbers are like sequential here. So if, for example, it's 3, 4, 5, and then number 5 is system information type 5, then you should use that version, not 3 instead of 5. But in this case, we have to use this one. But we can also use these and then add 102 to them. In case, for example, it says system information type 5, and then there's like ciphering mode command, and then over here it may say suddenly it jumps to 100 or something, then you can't use system information 5 here because then it's not in your stream. You can also filter this by using GSM tab, and then you can specify it by subslot. So the subslot for this one is 1. So that way you can more easily see the packets that you can use for XORing. So you can use this packet, you can use this you can't use this one. You can use this one and this one. That's the only packets that we can use in this case. Anyway, let's try and add some numbers together. So I've only added 2 because I know that we can crack some of it and we only need really 2 in this case. You can try up to 4, but you shouldn't try more than 4 for the same key. You should call yourself and then get a new key and then capture data again in case you can crack it by just trying up to 4. But you can also try with this 2 and then try and renew your key by calling yourself. So we will just use these 2. And now we want to use the, let's see, here it is. We want to use a big and nice console screen because the output from airprobe is in this file, and it's going to look a lot more nice when it's shown like this, when it's on one line, these ones here. So if we take a look at system information 5, we can press the / and then Control-Shift-V, and you can see it down here. Then we can press enter and we can see the system information 5 packet, and in case airprobe is able to decode it, then you can see it down here as well. So you'll be able to see it like this. In case it's unable to decode it, then it will be shown like this, for example. So we want to see if these frames exist. So we will just double click on this one and search for this number. Now in some cases you may not pick up 18, 19, 20 and 21. This is basically one packet inside Wireshark. So maybe you only have 19, 20 and 21. In that case, you can try and search for 19, 20 or 21. But you need at least 2 bursts in order to find the encryption key. So if you only find 21, for example, if I only found 21 in this case, then it wouldn't work. So yeah, but in this case, we have all 4 bursts, so that's very, very good. So we will just note that we have 4, and then we will try the next one. And that one exists as well. So that's very promising. So you can, let's see, you can use third-party tools, but they are mostly based on luck by the looks of it, because I've had a look at how they work and they're not really stable enough for you to work with. It's better that you do it manually to begin with, so you understand the process. So we will just delete these lines. And then we need to go back to this frame here. So we'll just question mark because it's upwards. So we need to use question mark. And then we will just copy these bytes here, because that is this packet, and I'll just confirm that there are enough bytes here. So after 9B in my case, there should be 1000 bytes. So that's very important, because otherwise you will have to re-record your video because you screwed up by missing 1 byte. So, yep. Anyway, you can also get it from Wireshark, and it's important that you get the bytes exactly as they are. If they're not, it won't work. So system information 5, and then you need to click this header here, and it's important that timing advance is 0, 0 here. If it's, for example, 5, then just copy the bytes, copy all the bytes from 0, 5, like here as I've highlighted, and then just copy all the bytes from here and then all the way down to here. And then make sure that you change this to 0, 0, because otherwise you may have issues. So, but in this case, it's 0 already, so that's fine. So the next thing that we need to do is that we need to use gsmframecoder. So we will just find it, here it is, and we need to supply it as follows. And then we will just copy this and paste it here. And we'll just move this up because we don't really need this information around. We only need the bursts. We only need these bursts, and then we only need the encrypted bursts. So encrypted burst 1, or it's actually a frame, encrypted frame 1 and encrypted frame 2. And these are potential system information 5 frames or packets. So the next thing that we need to do is that we need to XOR this with this and do it with 2, 3, and 4. So what we will do is that we will just create a new line, and then we will just copy these because we need these numbers. These numbers are used for A51 encryption. They are derived from this number here, and you will need them to find the encryption key if you crack one of these bursts that we are going to create. So we will just XOR 2. It's very important that you don't screw up this data, because otherwise it's not going to work. So now that we will just XOR some of the data, so I'll just make this window a bit bigger. And then we need to use XOR. You can get it from Kraken, and it's just a Python script, so you don't need to compile Kraken on your computer. You just need the XOR.py script. So just run XOR, or you can write your own XOR program. All you need to do is XOR these bits with these bits and so forth. So we will just do that now. So now that we have the XORed bits or bursts, then we can try and feed these to Kraken. So I'll just log into my Kraken server. Alright, so you need a Kraken server as I have, and then you need to run Kraken and load the tables. And then you need to wait a few moments. Now, before we start cracking the bursts, we need to crack, in order to find the encryption key, we need to crack a burst where we know the contents of the previous burst. So even if we crack this burst, for example, it's not going to help us find the encryption key. So we want to crack from 2, 3, and 4. So we'll just crack number 2 to begin with. And then we just wait, and we do the same thing down here as well. So we don't use this one, this first burst. We only use 2, 3, and 4. But we still need this in case we crack this burst. So in this case it cracked it, so I'll just see if it works. So I just have a second window on the same server. It's important that you use find KC on the same server that you cracked the key on, because otherwise it may not work, because I had some issues with that. So we'll just run find KC in utilities, and then we want to copy this, and then we want to say 15, and we want to use, this is the frame, the modified frame number, and we can run it and we get some mismatches because we haven't provided a second frame, but these could be potential keys. Now we need to supply a previous burst, so we'll just try and supply this because this is the previous one before. So we'll just try it. So in this case it didn't work, but we'll just continue and see if we can find one that actually works. So the first set didn't work, so now I'm trying the second set in hopes that the second set will work. So even though we did crack the burst, we couldn't use it to find the key, so that's unfortunate, but it does happen. So we'll just sit back and wait again. So now we can see that it has found a key, so we will try and use this key and see if we are lucky. So we will just use find KC again. Just copy this, and it's position 9, and it was this frame right here. So we will try and submit this frame here and this burst. Cross your fingers, see what happens, and it works. Yes. So now we got the key, and now we can try and decrypt our data. So let's try it. That was not it. Key. Let's minimize. Yep. Listen. Minimize. We'll just use this program. So we'll use GSM decode A94 186 channel, and then we will use E1, that's A51, and K is as follows. I think we need to remove the spaces first, and then we can try and run it. So we just need to remove the help flag as well, that will help. And it's certainly decoding stuff, but we need to make sure that we're also decoding the right channel. So we need to say SDCCAH and Timeslot 1 and try again, because that's where the SMS will be located at. And as we can see, there is an SMS here, so that's very promising. So if we take a look, we can see that there is an SMS here. If we scroll down, see that we decrypted our own SMS. Now if we just remove the filter, we may be able to see that we have sent ourselves multiple SMSs, so that's very cool. So we were even able to decrypt multiple SMSs with the same encryption key. So that's pretty much it, guys. Stay tuned and subscribe.